Hello friends, welcome back to my channel. And in this video, in this session, we are going to discuss about the retrieval step in the RAG pipeline. So this is almost the last step, and this is where we will be able to see the entire efforts and the required output for given query. So let's get started. And before I start, I just want to show a couple of things on my channel. If you see this particular AI generalist playlist. So here I've started all the RAG related steps. So first step is data collection, and then data conversion to converting into markdown, data cleanup and cross source deduplication, chunking strategies, again some chunking strategies, semantic chunking, and embedding step, then vectorization, vector database, and then RAG query encoder. So after this, there comes this step called as RAG retrieval. So we are going to talk about this, the almost the last step, and whatever programming we are going to see here, all the code is available here. Okay, and the link is in the description. Also the PPT, everything is there in the description. So let's get started. Now, RAG retriever. So far we have got the concept. We have done all the data related activities, and now we want to raise a query so that we will have to get the relevant chunks as an answer for our query. Okay, so RAG 2.8, step number 8, retriever. So it finds and returns the most relevant chunks from the database based on query similarity. Now we have done the semantic chunking and many other aspects, and we have stored it in different databases, different data structures. So now we want to retrieve it based on our query. So that is where this retriever finds it. Okay, so it is the bridge between your question and the data. So how it works? So there are different ways, different techniques. So one is simple vector search. So it converts your question into mathematical representation, basically an embedding, and then finds the similarity between the existing data and your question. Similarity match, yes, it scans the database of pre-processed documents to find text chunks that are mathematically closest to your question. So almost like this, but this is a bit different approach. Then the handoff, so it grabs the top few results, okay, the relevant chunks, and hands them to the LLM, that is, for example, GPT-4 or any other LLM we want to utilize. Okay, right, so let's see the implementation. So we will see the actual demos using simple vector store, then the sparse search, dense search, and reciprocal rank fusion algorithm. We will see. Okay, and we will also see, so this is from the development perspective, how developer will do it. And then if I want to test this retriever step as an automation person, how do I, what is one of the way to do automation? So we will see that. Okay, so let's get started. So first thing, retriever. Okay, so here I have this input data. Okay, this is basically talking about some info. So retriever is one step in the RAG, and what are the different aspects of it, the retriever, generator, olama. Okay, so by the way, I'm using olama wherever possible. Okay, because olama gives good credit and good AI models to be used for almost free for certain periods. So I'm using olama. Okay, you can use OpenAI also, or you can use any other LLM, but Olama gives something which is free, and it is a good model. Okay, so this is the text data. Make sure you have to start the Olama server, Olama application, and you can also start programmatically using Olama.serve. But if it is already there, then no use. I mean, it's of you can do it programmatically also. So for now, I'm commenting on this because it's already started. Now, character text splitter. So splitting the input data into some manageable chunks. Okay, using this character text splitter. This is again one of the text chunking strategies. So also used very widely. So 150 character chunks and overlap 20 characters, separation by new line, and those things. So I am generating the docs based on the text splitter, and I'm giving it to embedder. So Olama, I'm using this model, Nomic Embed Text, which is the local model I have downloaded. Okay, and yeah, create a local vector store. So this converts the text into vector store and stores them into memory. So Chroma vector I'm using LangChain Chroma vector. So there I'm storing, and then I'm going to do a vector store. This vector store dot retriever, and top one or two relevant chunks. So for now, for simplicity, I'm just fetching the only the top first chunk, but it can be top two, top three as per your requirement. Okay, so I have a query. How does retriever work? So if you see at a high level, this is the data, and if I'm going to chunk it, then there will be three documents created. Okay, so this is first document, second document, third document. So naturally, if you see retriever, this particular document is the most closest uh, document for a particular query. So the query is how does the retriever work? So retriever dot invoke and pass on the query. So remember, when it gives the results, it gives the top first result. Okay, I can say k equal to 2 also, top two results, top three results, but for now I'm using only one. Okay, and then the result. So let's run it. It's very simple. Okay, so this is the query and this is the answer where we should expect. Okay, so remember, this is, we can say it is an answer, but it is the closest match to a particular query. Okay, right. So okay, let's see next one. So next one, so we are doing something called as hybrid search, and we are also using reciprocal rank fusion technique. Okay, so how to do it? So let's say I have three docs already. So in this, if you see earlier, there was a data. So instead of that, I'm using everything as a doc. Okay, this document can be generated with whatever text splitter or any other chunking methodology. Okay, so then I have a sparse search and dense search. So what is sparse search? It is BM25. That is best match 25 style keyword matching simulation. um, this is again one of the algorithm which is also widely used in basically Elasticsearch, where it will find the best match. Let's say you are searching on any search engine and you want to search for some particular item. Okay, so let's say in e-commerce, so we are searching for a particular item. Let's say a watch. So BM25 will retrieve the most relevant, that is best match 25 results for a particular keyword. Okay, so that is where we are using sparse search. This is successful when we have a exact one to one or one to two, one to three relationship, but not for a full extended search. There's no intelligence much, it is just finding the relevant match. Right, so it relevance the, so finally what is this retrieval method? It will give you a document number which is the best match for a particular given query. Okay, then we have a dense search. So it is kind of semantic vector search simulation. So here it is using, in production we have to use this embeddings, so OpenAI sentence transformer, but for the sake we are using simple score mechanism, where the keywords which are mentioned in the query are available in the um, our documents or not. Okay, and based on that we are having some kind of a score. Now this we can go in detail, but for the sake of simplicity I have just put two different algo here, algorithms, sparse search and dense search. Now once I will call the sparse search and dense search, then both the things I will have to pass it to reciprocal rank fusion. So where what it will do, it will identify which documents are the closest match. Okay, so we got the documents that which, so this two will return most closest match. Okay, and this RRF will again refine that, so combines multiple ranked list into one using RRF algorithm. Okay, right. So again, some sorting and other algorithms are there, and based on the highest match, we are going to get the result, and we are going to sort it. Then the top first will be the closest match. Okay, right. Now for this particular data, of course, it's very small data, just three lines, three documents. What we're going to do, we are going to do a query for quick fox. Okay, so probably the quick fox, the document 1 and document 3 are the relevant match. Okay, and this is totally not relevant. Okay, right. So when we run this, we should see the score of each and every document up to fourth digit in the float, and we need to analyze which one is the closest match given. Okay, so if you say doc 1 and doc 3 are the closest match, but doc 2 is having lesser score. Okay, so we are going to sort it. and this is the highest score. So 0.0328, this is the highest, second highest, and this is the lowest. So the one which is very highest is the closest match. Okay, like this we can play around, and we can take different data, different domains of data. Let's say something in medical, something in um, day-to-day life, something in electronics, something in some other domain, and we can raise a query for a particular domain, and see how the ranking works. Okay, right. Now moving ahead, so this is the third part where it is basically re-ranking. So almost kind of similar to this RRF, okay, reciprocal rank fusion, but little detailed approach. And this time I'm using a model which is Qwen3 re-ranker. So by the way, I have downloaded this ranker module on my local. It is less size and it will not consume that much of RAM. So that model I'm going to use. I can use some other models also, but Qwen3 seems to be a bit popular. Okay, so if you see zero point 0.6 billion, so many parameters comparison it can do. Okay, and that will be helpful. So right, so first let us see. So I have this data. Okay, this chunks, this is stored in some database or whatever, and this is a query. So how do I optimize RAG retrieval? So if you see here, almost the top three lines are related to RAG. Okay, and this is something which is one off or not relevant. Okay, so how do I do re-ranking? So re-ranking documents, so I will call the re-ranking documents, and every document I will get the rank. So the rank, how the rank will be decided for every property or every document. Okay, so this time I am going to pass it on to Olama re-rank AI model, and that will decide is this query is more close to the document. Okay, right. Now if you see the temperature is 0 here, that means it is very deterministic approach. Okay, and these are the standard parameters we need to pass. So the model prompt options and stream equal to false. Okay, right. So once I get the rank for each and every document, then I have to re-rank it. So re-ranking is basically again collecting all the ranks, okay, and sorting, and I will have to get the let's say I want only top three results, top two results, so that I will get. So the one which is at the highest will be having the most closest match, and that I can give as a response. Okay, so remember it is not a answer, it is a response. So the response is basically most closest answer, most closest data chunks for your query. Okay, so once I get the rank, then I will reprint it. Excuse me. So the query is how do I optimize rank retrieval? So because this is taking time, because it is going to talk to Ulama and going to make a network call, so that is why it is a bit slow. So how do I optimize RAG retrieval? So to optimize RAG, focus on chunking. RAG stands for retrieval augmented generation. Okay, so these are the two closest match as a response for a particular query. Okay, right. Now we have seen a couple of approaches. Now let us see the automation, because practically, let's say there is a LLM we have to test, or some RAG model we have to test, and for that we obviously will have huge chunks of data. So how do you do automation for that? So almost similar. So if you see here, the test data is having so many rows. Okay, let's say 40, um, yeah, 30 rows are there. So how do you do it? So first of all, let me just comment it out, because this Olama is already running. So I'm again using a text splitter Olama embedding. So I can use a different Olama embedding model. If you see here I have used this SAM860.3, but here I am using Nomic embed text. This is also one of the good model, also used in my earlier demos and videos. So here I'm going to store it into Chroma vector store. I'm going to simply retrieve and the queries. So I have a huge data, okay, and have some additional queries. So these are the queries which are probably will find most relevant match, and these are the queries where there is no relevant material available in the source data. Okay, so we will see first the one which is happy path. So we simply use a for loop, and then we will use vector retrieval. Instead of that, we can also go for this particular re-ranking and other things, but for automation perspective, I've shown a simple demo. Okay, so let's run it. So there are so many questions. So let's say take some random questions. So what advice is given to patients to prevent asthma? So to prevent, okay, this is related to some medical healthcare and also medical healthcare. So this is relevant uh, response for a healthcare related question. Okay, so let's take. Okay, so everything seems to be related to healthcare and medical. So this is, I would say, it is good match. Now let us take something which is not related to healthcare or not related to medical. Okay, so let's take this one. So all the data which I have is related to medical or healthcare, and I am asking, something Windows, something recipe, some sports, some astronomy, and some trekking related things. So this is not even relevant. Okay, so let's see what response we get. Okay, the FIFA World Cup. So for FIFA or sports, it is giving some healthcare related information or response. Chocolate recipes is related to cooking. So again, it is giving something which is not relevant. And Windows password. So this is again not relevant. So one point I want to make here is whatever query we are giving, so the algorithm or the backend will simply find the most relevant match from the given data. So if there is not most relevant match, then it will go to the second relevant or third relevant or fourth relevant or fifth relevant. So like this, it is giving us a response. Okay, so we need to be careful, okay, what questions we are asking, and we need to see what answers or what response we are getting and if it is really relevant or not. Okay, right. So that is all about the retrieval step. So yeah, so if you like the content, if you like the video, then please like, subscribe to my channel. Thank you.